Imagine a world where the sky isn't blue, but a violent, streaking azure, where storms don't bring rain, but shards of molten glass. This is HD 189733b, an exoplanet so hostile, it redefines our understanding of extreme weather. Forget gentle showers. Here, winds howl at supersonic speeds, carrying silicate particles that flash freeze into deadly rain. Join us as we journey to this terrifying, glass-shattering world and uncover the cosmic forces that shape its monstrous climate. You won't believe what's happening just a few hundred light-years away. HD 189733b, a blue world. HD 189733b presents a striking azure hue, a visual characteristic that immediately captures attention. This deep blue color is not due to oceans or atmospheric gases as we know them on Earth. Instead, it originates from silicate particles suspended in its atmosphere. These particles scatter light in a manner that emphasizes blue wavelengths, much like Earth's sky is blue, but with a far more intense and alien quality. The planet orbits a star similar to our Sun, located about 63 light-years away in the constellation Vulpecula. Its proximity to its star, however, results in extreme conditions. This exoplanet is a hot Jupiter, meaning it is a gas giant similar in size to Jupiter, but orbiting incredibly close to its host star. This tight orbit leads to scorching temperatures. Daytime temperatures can soar to an estimated 10 degrees Celsius, 832 degrees Fahrenheit. Such intense heat has profound implications for the planet's weather systems, creating an environment unlike anything found in our solar system. The planet is tidally locked, with one side perpetually facing its star and the other in eternal darkness. The silicate particles in the atmosphere don't just create a beautiful blue color. They are also the source of its violent, glass-raining weather. When these particles condense in the upper atmosphere, they form droplets of molten glass. These droplets are then swept by ferocious winds, reaching speeds of up to 700 kilometers per hour, 400 miles per hour, or 7 times the speed of sound on Earth. Imagine being caught in a storm where not water, but liquid glass, is hurled at you at supersonic speeds. This makes HD 189733b a world of extreme, almost unimaginable, meteorological phenomena. The constant bombardment of glass shards and the extreme temperatures create a hostile environment. The planet's atmosphere is a dynamic and dangerous place. While its blue appearance might seem serene from a distance, the reality is a chaotic and violent atmosphere where glass rains down relentlessly. This unique combination of a vibrant blue color and deadly glass storms makes HD 189733b a fascinating subject for astronomers studying exoplanetary atmospheres and the diverse range of conditions that can exist beyond our solar system. Extreme temperatures and atmospheric conditions. HD 189733b experiences scorching temperatures on its day side, reaching a blistering 10 degrees Celsius, 832 degrees Fahrenheit. This extreme heat is a direct consequence of its close proximity to its host star, a red dwarf. The planet is tidally locked, meaning one side perpetually faces the star while the other remains in eternal darkness. This results in a stark temperature contrast between the two hemispheres, though the night side is still incredibly hot, estimated to be around 500 degrees Celsius, 932 degrees Fahrenheit. The atmosphere of HD 189733b is not only hot, but also incredibly turbulent. Winds howl at speeds exceeding 700 kilometers per hour, 400 miles per hour, making them the fastest ever recorded on an exoplanet. These ferocious winds are driven by the extreme temperature difference between the day and night sides, creating a chaotic and dynamic atmospheric system. Perhaps the most striking feature of HD 189733b's atmosphere is the presence of silicate particles. Under such immense heat and pressure, these particles form tiny droplets of molten glass. The high-speed winds then whip these glass droplets around, creating sideways rain of glass. This phenomenon is responsible for the planet's deep blue hue, a color caused by the scattering of starlight by these glass particles. The atmospheric conditions are so severe that they defy earthly comparisons, presenting a truly alien and hostile environment. The phenomenon of raining glass. On the exoplanet HD 189733b, the weather is unlike anything experienced on Earth. Instead of water, the atmosphere is laced with silicate particles. These particles, under the extreme conditions of the planet, can form glass. Imagine winds that reach thousands of miles per hour, far exceeding the speed of sound. These ferocious gales scour the planet's surface. As these super-fast winds whip through the atmosphere, they carry the silicate particles. When these particles are forced into cooler regions of the atmosphere, they condense. This condensation process can lead to the formation of tiny shards of glass. The glass then falls from the sky. It's not a gentle rain. It's a violent, abrasive downpour of molten or solid glass. The temperature on HD 189733b plays a crucial role in this phenomenon. The side of the planet facing its star experiences scorching heat, while the other side is comparatively cooler, though still incredibly hot by Earth standards. This temperature differential drives the extreme winds. Within the atmosphere, where temperatures are just right for condensation, the silicates transform into glass. This glass then cascades down through the atmosphere. The visual of glass raining from the sky is both terrifying and awe-inspiring. While we cannot directly observe this process due to the immense distance, scientific models based on the planet's atmospheric composition and temperature predict this extreme weather. The silicate particles, likely rich in iron and silicon, are swept up by the planet's violent winds. As they are transported to cooler atmospheric layers, they solidify into glass, creating a deadly, glittering precipitation. Silicate particles in the atmosphere. The atmosphere of HD 189733b is laden with silicate particles, tiny fragments of glass that are whipped around by ferocious winds. These particles are not merely suspended. They are an active component of the planet's extreme weather. Imagine winds exceeding 50 miles per hour, creating a perpetual storm where glass shards are the precipitation. This is not rain as we know it, but a scouring, abrasive environment. The silicates are thought to form high in the atmosphere where temperatures are cooler, then are driven down into the hotter layers by the planet's violent atmospheric dynamics. These microscopic glass fragments, likely composed of materials such as instatite or forsterite, play a crucial role in the planet's visual appearance and thermal properties. Their presence contributes to the deep blue hue observed from afar, scattering light in a manner similar to how Earth's atmosphere scatters blue light. Though on HD 189733b, the effect is dramatically amplified by the exotic composition. The constant abrasion from these particles would make any solid surface utterly inhospitable, sandblasting it into oblivion. The exact mechanism for the formation and cycling of these silicate particles is still a subject of intense study. Models suggest that the extreme temperature gradients between the day and night sides of the tidally locked planet, coupled with the powerful jet streams, could facilitate the condensation of silicates in the upper atmosphere. As these particles are transported to lower, hotter altitudes, they may re-vaporize, only to condense again in a continuous, violent cycle. This atmospheric churn ensures that the glass particles are a pervasive element of the planet's weather system. The sheer energy involved in this process is staggering, far exceeding any weather phenomena experienced on Earth. Winds and weather patterns. On HD 189733b, the weather is far from tranquil. This exoplanet experiences some of the most extreme wind speeds ever recorded, blasting across its surface at an astonishing 500 miles per hour. That's 7 times the speed of sound on Earth. These ferocious winds are driven by the intense heat radiating from its star, a red dwarf that bathes the planet in scorching temperatures. These winds are not just fast, they are also incredibly turbulent, creating chaotic atmospheric conditions. The atmosphere of HD 189733b is a swirling cauldron of silicate particles. When these particles are whipped around by the supersonic winds, they form a glass-like rain. Imagine skies filled with shards of glass, hurled horizontally at incredible speeds. This phenomenon occurs on the day side of the planet, where temperatures soar to a blistering 800 degrees Fahrenheit, 982 degrees Celsius. The constant barrage of glass would make any surface utterly inhospitable. Darkness prevails on the night side, yet it offers no respite. While the temperature drops significantly, it remains hot enough to prevent the glass from solidifying completely. Instead, the silicate particles may form a thick, viscous atmosphere. The extreme temperature difference between the day and night sides fuels the relentless, planet-girdling winds. This perpetual tempest ensures that HD 189733b is a world of constant, violent atmospheric upheaval. The weather patterns here are a stark reminder of the diverse and often hostile environments that exist beyond our solar system. Implications for exoplanet research. The study of exoplanets like HD 189733b, where glass rains from the sky, profoundly impacts our understanding of planetary formation and atmospheric dynamics. Such extreme conditions challenge existing models, pushing scientists to refine theories about how planets form and evolve in diverse stellar environments. The existence of a hot Jupiter with such a violent weather system provides a crucial test case for atmospheric models, particularly those dealing with silicate clouds and high-temperature chemistry. Understanding the precise mechanisms behind the glass rain, how silicates vaporize at high temperatures and then condense into droplets as they cool, offers insights into the complex interplay of temperature, pressure, and chemical composition in exoplanetary atmospheres. This detailed analysis helps us predict the diversity of planetary atmospheres and identify potential biosignatures in other systems. Investigating the winds on HD 189733b, which can reach supersonic speeds, offers a unique laboratory for studying fluid dynamics under extreme conditions. These winds are not only responsible for transporting materials that form clouds and rain, but also contribute to the planet's overall energy distribution. The sheer velocity of these atmospheric currents suggests powerful convection and heat transfer mechanisms at play, far exceeding anything observed in our own solar system. By observing how these winds interact with the atmosphere and the stellar radiation, researchers gain a better grasp of atmospheric circulation patterns on exoplanets, which can vary dramatically depending on the planet's mass, radius, and proximity to its host star. This knowledge is vital for interpreting observations of exoplanetary atmospheres and for developing more accurate predictive models. The detection of specific atmospheric components, such as water vapor and methane, on HD 189733b, despite its harsh environment, highlights the resilience and complexity of planetary atmospheres. Even under conditions where glass rains down, fundamental chemical processes continue, shaping the atmospheric composition. Analyzing the spectral data to identify these molecules and their relative abundances provides clues about the atmospheric chemistry and potential geological activity. This detailed atmospheric characterization is essential for distinguishing between different types of exoplanets and for assessing their potential habitability, even in systems that initially appear inhospitable. The continued observation and modeling of such extreme worlds expand the scope of exoplanetary science, moving beyond Earth-like analogs to encompass the full spectrum of planetary possibilities. So, next time you gaze at the stars, remember HD 189733b, a world where the wind howls at supersonic speeds, carrying silicate particles that fall as searing glass rain under a cobalt blue sky. It's a stark reminder of the extreme and alien nature of the cosmos, pushing the boundaries of what we consider habitable. What other bizarre weather phenomena await discovery? Join us next time as we journey to a planet where it rains diamonds.